Hello guys, so in this video here I'll be talking about pointer notation in 2D arrays, and I'll try to explain the following. So I'll map each element address, show how you dereference the address to get a value, um, and I'll explain some nuances with respect to the base address of the first element and the base address or the starting address of the entire array block. And then I'll try to correlate the subscript notation of a 2D array to the pointer notation. So let's look at this here now. Now I have a 2 by 2 array here, right? 2D array. And the base, the name of the array is ARR. So the base address will be ARR. That is what I have here. Now, what I mean by having 2 by 2, the first two here is saying we have two 1D arrays. So this is one of them, right? You can just draw this line. If you don't mind. Yeah, so this is one 1D array, and then we have the second 1D array, right? What color I should use here? So you can just try to understand this. Good. So that's what this 2 is talking about. It's talking about this here, right? And this here. Now, that's the first thing you need to understand. So you have two 1D arrays, and within each 1D array, you have two elements. So this here, 1, 2, 1, 2, two elements, right? Good. Now we know that the base address of the array is the name of the array, of the first element of the array. So this ARR here is the first element, this block here, right? So this will be ARR. So the next block is going to be ARR plus 1. But within this first one, the array, there are two elements. To know the address of the first element within the first one, the array, we have to dereference this address. So that's why you have asterisk AR plus 0, which is like the first element here, right? So, and that's how we have asterisk AR plus 1, jumping to the second element within the first one, the array. To get the value 1 here, that would entail taking the address at this point here and dereferencing it. So I would have something like ARR plus 0, dereference this, right? Will give me 1. All right. If I want to find the value 3 here, the address here so I have the address here of the first element in the second one, the array is asterisk AR plus 1 plus 0. So I'll have to do a dereference this address ARR plus 1 plus 0, and this should give me a value of 3. Now this is equivalent to saying ARR of 1 of 0, because this here is ARR of 1 of 0. So you see this one here, it's like I and this is J. So this is I and this is J. All right. Now start to see that idea. This is correlating the subscript notation to the pointer notation, right? So if you can understand this drawing and understand how we set up the addresses, um, you'll get a good insight into arrays in terms of working with them, um, like using pointer notation. Okay, so the next thing we should look at, what could be something, you see here we have ampersand ARR, here we have ARR, here we have asterisk ARR. Now, ampersand ARR is the starting address of the entire array block. ARR is the starting address of the first one, the element, or the first one, the array, which is going to be the base address of the array. And asterisk AR plus 0 here, asterisk AR is the first element within the first one, the array. So you want to know what are the different, what address each one of these have, and I'll show you that in code. All right. So if you can, I can go through this this block a little more. So we have a 2 by 2 array. This first two here is telling you I have two 1D arrays, and each one of these 1D array has two elements. So that's what I have here, 1 2 1 2. And then the base address of the array is given by ARR. So that's what we have here. ARR is the base address of the first element, right? So this is the first element. Dereferencing this will give us the base address of the first element within the first element, right? Dereferencing this will give us the value of the first element. So you can see ARR here, and here is ARR plus 1. Now, what if you had a scenario where in the second bracket here you had 3, instead of 2 you had 3? Then you would have a next box here, next one here. You would have 3 elements in each of the 1D arrays. All right. Okay, so we'll go to code now and we'll look at this. Now I run this before, but um, I'll do it again. So for you to get a good view of this, I might want to have a clean background for you. All right, so we're going for array 2D v2 dot c arr 2v2 arr 2v2. All right. So just in case, I'll just show you here now. I'll try to relate to this drawing. What I have here. So you have this array, right? And it's int arr 2 by 2 is equals to 1, 2, 3, 4. So you have two blocks. Two 1D arrays. So the first 1D array will have a base address of ARR, and the second 1D array will have a base address of ARR plus 1. But within this first 1D array, you have two elements here, right? And here you have two elements. And here is ampersand ARR. Now, let's just look at this and this. ARR and ARR plus 1. ARR is 76. And what is ARR plus 1? 84. So that is 8 bytes. So what we're saying, this guy's starting address here is 76. So 4 bytes gonna make this 80, and this starting address is gonna be 84. This here is gonna be 88. So out here is gonna be 92 starting. Now look at ampersand ARR plus 1. See, you have 92. So you're taking care of this entire block. But AR is 76. AR plus 1 is 84. But ampersand AR plus 1 is 92. All right? So that explains. Oh, you would have noticed that explains the difference between the address of the entire array block versus the address of the first element of the block, and how pointer arithmetic kicks in based on the fact that we are using integers here. So we have 4 bytes for each integer, right? Now let us try to um, look at the next aspect of the same array. Oops. Okay, don't worry. I'll drive back. You get more practice like that, right? So we're dealing here with int ARR 2 by 2 is equals to 1, 2, 3, 4. Now, we have this big block. Within this block, we have two 1D arrays. So this is 1, this is 2. Within each 1D array, we have two elements. One, two, one, two. And the value contained here is 1, 2, 3, 4. We know that the address here is ARR, and this is ampersand ARR. The address here is asterisk ARR, right? And the address here gonna be asterisk of ARR plus 1, right? Now the address of this second block here is ARR plus 1. The address of the first element here is, we have to do an asterisk of ARR plus 1. The address of the second element here is going to be asterisk of ARR plus 1 plus 1, right? Because this is like plus 0 is here, and this is plus 1. So let us look at, let's see, for how we get a value 3. So we look at this here. We have the base address ARR is 76. So this address here, let's just change colors so you see this thing well. So this base address here is 76. Now you see that this ARR and asterisk ARR, they have the same base address. So this is also 76. So this must be 80. This is gonna be 84. This is gonna be 88, and out here gonna be 92. But you're seeing that ARR plus 1 and asterisk of ARR plus 1. Let's look at these two. This address here and this address here. ARR plus 1 is 84. And asterisk of ARR plus 1, right? Everything asterisk is also 84. So you want to look at this, and you want to look at this. And correlate all of this. These two, and just link it into this. What do you see? And we're talking about this address here and this address here. Now, if you try to go through this, there's a lot of stuff that you can derive from this drawing and with this code. So I will stop here for now, but before I stop, I want to make this correlation for you. You can see that, let us say this is this element here is going to be a of 1, 0. You can see this is the same as dereferencing of asterisk ARR plus 1 plus 0 is the same. So what am I saying with all of this? I'm trying to say this. That A I J is the same as asterisk of A plus I plus J. So let's correlate back that here. If I'm looking at A0, 0, that's where we have 1. That is here, right? So I have A of 0, 0 is equals to asterisk ARR or A plus 0. So that still remains that plus 0. Now, let's look at two. Let's look at 3. So I have A of 0, A of 1. Why am I doing this? A of 1 of 0 is the same as, now this is equals to 3. And here I have asterisk of A plus 1 plus 0. Now this is like saying this is I and J asterisk of A plus I plus J. All right. So guys, I will stop here. You could try running this code and you'll see what I'm saying. So I'll just give you an idea of the code. Let me just give you that. Cat array 2D v2 C. Here's my code. So you can pause this and try to read the code and try this out. All right, but I think this is all what I can offer right now. So I'll stop this video here. If you don't mind, subscribe to my channel, Spectrum 1844, for more videos on C and C++. All right. So you guys have a good night, man. Bye.